Many motion editing operations involve blending, wherein motions are combined according to time-varying weights. One important blending application is transitioning, such as between a walk and a jog. Blending can also be used for interpolation. Here we interpolate jogging and sneaking motions to produce a stylized jog. In this video we present a new technique for automatically generating blends. Our method uses a novel data structure called a registration curve, which encapsulates relationships between the timing, coordinate frame, and constraint state of an arbitrary number of motions. This information is used to blend motions that cannot be handled by standard automatic methods. Blending can produce artifacts if timing differences are not accounted for. Registration curves use automatically generated time warps to blend motions with significantly different timing. Time warps can be created for arbitrarily many motions. Each column in this figure shows frames matched by our algorithm. Standard automatic blending methods combine root parameters with linear interpolation. If the paths of the characters are not similar, this can produce serious artifacts. Registration curves avoid this problem through a novel technique called coordinate frame alignment. Coordinate frame alignment can be used to blend motions with very different paths. Here we blend a straight walk with one containing a sharp 180-degree turn, allowing us to generate motions with intermediate turning angles. Note that the character pauses naturally during the execution of the turn. Some motions have fundamentally different constraint states. For example, jogging contains periods of flight while walking does not. Simply copying constraints from one of the input motions into the blend can produce artifacts. Here we have interpolated walking and jogging to produce a trotting motion. The character's feet appear to stick to the ground. Registration curves provide a mechanism for identifying logically related constraints, allowing better constraint blending. This method is applicable to motions with significantly different constraint states. Here we blend standing still with a 180-degree turn, yielding intermediate turning motions. Registration curves interface seamlessly with standard blending applications. A user can create a transition simply by specifying its length and the pair of frames about which the transition is centered. Registration curves can be used as a back end for motion interpolation, allowing one to create parameterized clips. With these three kicking motions, we can build a continuum of kicks with different amounts of snap and lunge. Here we have a clip parameterized on the launch direction of a backspring. Blending weights may be constantly varied to give continuous control of the character. Here we show a motion generated from a registration curve that contains 9 kinds of locomotion. creating a space of motions parameterized on speed, turning angle, and sneakiness. The arrow in the upper left is a visualization of the current parameter settings.